One of the things that computers are not great at is making decisions. So we have to translate human decisions into a method that computers can understand. Computers are very black and white, meaning you have to end up reducing all decisions down to one of two possible outcomes: true or false. This true or false value is called a Boolean, and it's the fundamental logical building block of all the decisions you're going to ask the computer to make. Booleans are generally formed by what we would call a relational operator, meaning you take two pieces of data or variables or information and you ask the computer to relate them to one another, deciding whether that overall relationship is true or false. Let's look at some relational operators. So for example, you could check if two pieces of information are equal to each other. So does 1 + 1 = 2? Yes, it does. So this would result in a true decision. Then you can see that there's less than, greater than, less than or equal to, greater than or equal to, so on and so forth. So this is a great way for you to use your two variables to decide how they're related to one another. You always have to figure out how to break this down to a true or false value in order to use some of the control structures we're going to talk about next. One of the most basic control structures is the if statement. You can think of this as a branch in your code. Essentially, it's a little piece of code that you only want to run if a Boolean is true. So maybe you only want to run it in a special case, or you only want to do it if something goes wrong. If that's the case, you can sort of section off a piece of code, wrap it with a Boolean test, and if the test is true, that code runs. Otherwise, it gets ignored. Here's the syntax for an if statement. You start with the word if, and then a set of parentheses, and then your Boolean test. If that test evaluates to true, then whatever statement is contained within the curly braces of the if statement will be run. Otherwise, the computer just jumps down to the line after the if statement. You can kind of picture this in this flow diagram, where the computer comes in and looks at the Boolean test. If it's true, it goes on to run the code inside of that, and then runs the code after it. But if the Boolean test is false, it just skips that line of code and moves on. Sometimes you want the result of a decision to be one thing or the other. So I only want this to run if this is true, else I want something else to happen. This is called an if-else statement, and this is the syntax for it, where you start with an if just like you did before, but then after the closing curly brace of the if, you put the word else, and no test. Now you've got a decision. You've sort of got two mutually exclusive pieces of code. So either they come into the test, and if they're true, they run the thing in the if, and if it's false, it runs the stuff in the else. Then it finally goes on to the code after the if-else statement. You're guaranteed only one of these things will happen. That's why the if test checks one thing, and then it automatically runs the else test if that's false. Well, it can get more complicated. Sometimes you need more than two outcomes. Sometimes you need an unlimited number of outcomes. That's where the else-if clause comes in. You would still start with your if statement, and then you would follow it up with another test. To do this, you add the words else, if, and then another Boolean test. And actually, you can add as many else-ifs as you want. So you could have one if statement, 10 else-ifs, but it always has to end with that else, so that you always have something that is guaranteed to happen. You can think of it sort of like this, or you then have sort of a chain of tests that you're going to check. Now, as soon as the computer finds a test that evaluates to true, it's going to run that clause and then leave. So you need to be very smart about how you organize your tests, because sometimes you can have situations that would cause multiple tests to evaluate to true. So it matters what order you put the tests in. It can get even more complicated. Sometimes you have sort of layers of decisions, meaning, okay, in this statement, or in this case, I want to run one thing. In this case, I want to run a whole series of different things. You can actually put if statements inside if statements. This is called a nested if statement. You can kind of think of it like this, where it's sort of a cascading layer of tests. So you could have, within an if statement, you could have a whole if else tree. This can get pretty complicated when you're writing the code. Sometimes you only just want something to happen when there's two tests. You can actually combine tests with another operator that we haven't talked about before. This is the AND operator. So what this code does is it checks if both the tests are true, then it runs the code in the if statement. This is essentially the same as nesting an if statement and might simplify your code if you just have kind of a simple dual statement solution to do. Here are some of the other operators that you could do. You can do ands, ors, or not. Ands mean both of the Boolean tests have to be true in order for this to run. The or means as long as one of them's true, it's going to run. And the not, or the bang character, just means if it actually evaluates to false, flip it and evaluate it to true, and vice versa. You can think of these things in sort of a table format where if A and B are different Boolean tests, based on their outcomes, here's how anding them or oring them together would eventually result. If you're trying to use an if statement, it all has to boil down to a single Boolean at some point. So this way you can combine multiple Boolean tests eventually into a single decision. Strings, unfortunately, can't use the relational operators like the less than or greater than symbol. For example, if we checked if a string was double equal sign equal to a string, we'd get an error. That's not how strings work, unfortunately. They're more complicated than numbers, so we have to use a special equals method provided to us by the string class. And this is true of any time you're using an object in Java. In fact, the strings have lots of different comparisons that you might want to make that are distinctly different from numbers. Here are some of the most common ones. You can check what strings start with, if they contain letters. All of those sorts of things will result in a Boolean. And you can look at Oracle's string documentation to get the full list of comparisons you can do that result in a Boolean in the case of strings. Understanding how to control the logic within your program is going to let you create far more complicated programs. These are programs that can make decisions, that can be contextually aware, and can do lots of different things based on the scenario. So mastering Booleans is an incredibly important part of learning to code.